Hello everyone, once again with the integration by parts. Previously we have learned the procedure how we can do the integration by parts, right? We have to choose two, we are given two functions and any one of them will first, any one of them will second. Now we have some examples where we are having only one function. In those conditions what we have to do, just we have to look after. Say the question come to us is integration of log x dx. That is alone function I have, right? So in those cases what will happen guys, we have to use that function log x as a first and 1 as a second. That is important part where the question comes in a single format and that function will treat as a first and 1 will treat as a second. One is the number which is integrable as well as differentiable, so we can treat it as a 1. Now we should apply the by parts method. Log x, drop the first function, say it is integrate second. Integration of 1 is what? That is x minus, and differentiate the first function. The differentiation of log x will come to us is x, and that function will repeat again, that is x and what? Dx. Similar, so there is x and log x is there, minus this x and this x will be cancelled, remain here dx, then here is, and now finally we have to integrate it, and then integration of log x come to us. Here is x log of x minus of x plus of c. Now onwards we people having a result for us. What's the result is? Integration of log x dx. That result is x log of x minus of x plus of c. This result can be precise in a more formats. There is log x minus of 1 plus of c. Sometimes we can write it like that. And one more time, here is x, there is log of x on basis e, minus this one can be written as log e on base of e plus of c. We can say this, and here is x, and then again it is what? Log of x by e, like that, and plus of c. This result can be compiled at. So we people have to use it accordingly. That is simple log of x. Another question we are having that, and the question says is what? Here is log of x whole square dx. Another question for us. Again, we are having a single function, log of x whole square. In that function also, what we have to do? There is log of x whole square that will treat as a first, and 1 alone will treat as a second, and then dx. And again we have to apply integration by parts. So according to that rule, what should we do? We should drop the first one. Say it is dropped. Integration of the second function, that comes x, minus the differentiation of first. So we have to differentiate this entire portion. Function to function we have to deal. First the power should be there. So there is 2 log of x, and then differentiation of log x is 1 by x. And this part should be continue, that is x and what? Dx. So we have to be take care while we are doing differentiation, etc. This x will comes out, and inside portion is x log of x whole square. The base is always e. This x and this x will be cancelled, minus of 2. Inside portion again there is log of x and dx. Now further what we have to do? There arises another term, log x again. So again we should apply the same methodology. There is x log of x on basis of e whole square, minus of 2. Say inside the bracket I am putting here, there is log of x, it will treat as a first, and 1 again it will treat as a second, and then dx. What we did, log x comes again, so log x will be the first and 1 will be the second. Here is x of, there is log of x of whole square, minus of 2. Now we have to integrate again. So drop the first function, there is log x will be there. Integrate second, integration of 1 is what? X, minus of differentiation of that portion, log x is 1 by x. This x will continue, and what? Dx. And finally we have the conclusion, x log of x whole square minus 2, and this x should be first. There is x log of x minus this x and x will cancel, integration of dx will be x and plus of what? C. That is our solution. And one more step, we have to open the bracket and it will be over. So there is x of x log x minus of 2x of log x and plus of 2x plus of c. That is the problem we have. So in both the problems we can see here is only one function and we have to suppose one as the another function. In some of the question of by parts, what will happen? Some questions are we are having like this also. Say where the functions repeat itself. I repeat, where the function repeat itself. So I am taking another type of question here. Say integration of sec cube x dx. That we have to find out. Fine. So what we can do here in those problems, how we can do that? Say it is let I equals to, here is sec cube x dx. That is a lone function. So if I am doing one as a part, then it will be difficult. So what we can do? We can split it. We have to split it. So here is sec x and I can do is a sec square x dx. The two components of them. In both of them, this sec square x is integrable. In place of that, I am able to write tan x directly because tan x differentiation is sec square x. And I am able to differentiate that portion. So it will treat as a first and it will treat as a second for us. Fine. Say that was I earlier, it is first. Now I should apply the by parts again. So what should I do? I should drop the first. So sec x will be as such. And integration of second, integration of sec square x, that comes to us is tan x minus. Again, now differentiation of this first function come inside. Sec x differentiation is sec x tan x. And this portion will continue. That means to say tan x dx. We are using by parts integration method to find out integration of sec cube x. Now further, what we have to do, that portion is over, so I should write that. Here is sec x and what? Tan x minus inside the bracket. Again, I have sec x and tan x, that becomes here again tan square x and dx. Now next is, here is sec x and tan x, it will be outside, minus inside portion, there is sec x. In place of that tan square x, I am writing again sec square x minus 1 are trigonometrical identities. Then what will happen now? This portion is what? Sec x and tan x. That will be continue minus, just open that bracket. It come to us as sec cube x minus of sec x and dx. Now it's a time for remove this part. So there is sec x and what? Tan x minus, open the bracket and isolate them. It becomes sec cube x dx, and this minus and minus plus, an integration of what? Sec x dx. Now see guys, in the left hand it was previously I. It was supposed as a I, and again in those portion this is again what? I. In place of this I can write I again. So we have to write that. So there is sec x and tan x. In place of this entire portion I should write again I, and plus integration of sec x is what? That is log of sec x plus tan x. And plus of what? C. And in the left hand side, don't forget it is I. Now this I should be transposed in the left hand side and becomes 2i. So we have to be, there is 2i in the right hand side, it comes now. There is sec x and tan x, and plus there is log of sec x plus tan x, and plus of what? C. And just divide with the 2. Then finally I comes to us, there is sec x tan x by 2 plus of, there is log of, and again it is sec x plus of what? Tan x again by 2, and plus some another constant c dash. What is c dash? C dash is c by 2. Since it was a constant of integration, so in place of that we are able to write that. So that is another method of your by parts integration. Such type of question can be resolved by using that methodology. So that is a very interesting method we have, and we are able to put that anywhere. Thank you very much.